Assalamualaikum and hello everyone. In this video, we will discuss question 5 and 6 from PSPM SK025 2021-2022. Let's first start with question number 5. Reaction of benzene with isopropyl bromide in the presence of aluminium bromide give compound E. Oxidation of compound E forms compound F. A. Draw the structural formula of E and F. B. Explain why compound E undergoes oxidation. C. Write the reaction equation for the formation of compound E. And D. Write the mechanism for the reaction in C. Okay, so in this case, kita boleh lukis dulu the structure of isopropyl bromide. So we have the isopropyl group and bromine atom. So this is isopropyl bromide. In the presence of aluminium bromide, which is a Lewis acid catalyst. That means this is a Friedel-Crafts alkylation reaction, which means compound E must be an alkyl benzene. So if benzene react with isopropyl bromide, compound E must be isopropyl benzene. Okay, let's proceed to the answers. For question A, draw the structural formula of E and F. E is isopropyl benzene. And then oxidation of E produce compound F. So E is an alkyl benzene. Oxidation of alkyl benzene produce benzoic acid. That means compound F must be benzoic acid. I'm sorry for my drawing. Apparently it's not working for me tonight. Okay, benzoic acid. Next, let's proceed to question B. Explain why compound E undergoes oxidation. Okay, if we take a look at compound E, at this isopropyl group, you can see that there is a hydrogen atom attached to the carbon bonded to the benzene ring. So this is what we call a benzylic hydrogen. So if we need to explain why compound E undergoes oxidation, it's simply because compound E has benzylic hydrogen. Okay. Next, question C. Write the reaction equation for the formation of compound E. So write the reaction equation for formation of isopropyl benzene. We have the benzene ring reacting with isopropyl bromide to produce compound E. Okay. Lastly, question D. Write the reaction mechanism for the reaction in C. That means you are being asked to write the reaction mechanism for Friedel-Crafts alkylation reaction. Okay, if you remember, the reaction mechanism comprised of 3 steps. Step number 1, formation of electrophile. Step number 2, formation of uranium ion. And step number 3 is loss of H plus or deprotonation of the benzene ring. Okay, let me just scroll the whiteboard up a bit. And then we can continue with question D. So step 1, formation of electrophile. Okay, we have the isopropyl bromide and the Lewis acid catalyst, aluminium bromide. One lone pair from the bromine atom will attack the Lewis acid catalyst AlBr3, forming first a complex, Okay, where now this bromine will have a positive charge and the AlBr3 will have a negative charge. And then, okay, this complex will break to form a carbocation where two of the bonding pair electrons, okay, this bonding pair electrons from the CBr bond will both go to the bromine with positive charge, forming the carbocation and AlBr4 minus. So I'm just drawing according to what I did, okay, here. That's for step 1. Okay, electrophile is the carbocation. So next, let's proceed to step number 2, which is formation of arenium ion. Okay, in step number 2, benzene, okay, benzene, which is a high electron density reagent, okay, or nucleophilic site, becomes the nucleophile. Okay, so in this case, one of the pi electrons in the benzene ring will attack the positively charged carbon in the electrophile, forming the arenium ion. Okay, you have to show all three structures, all three resonance structures for the arenium ion. So this is structure number 1, and then structure number 2. So let me just show that we can move this pi electron here. Oh, tak nampak. Sebentar, sebentar. Okay, kita letak kat luar lah. Okay, you can move this pi electron here. So in the second resonance structure, the double bonds are here and here. So the positive charge will be here, and then this pi electron can be moved here. So giving you the third resonance structure. Sorry. Okay, so I finished all three resonance structures along with this positive charge here. Okay, ingat tunjuk tiga-tiga structure of arenium ion. And then lastly, step number 3, which is loss of H+. Okay, so let me just scroll up a bit to make some space. Okay, for step number 3, you can choose either one of these 3 resonance structures for arenium ion. Okay, you can choose either one. So I will just choose the first one. Let's draw the first structure. Oopsie. So loss of proton will come by regeneration of the Lewis acid catalyst. I keep writing it as AlCl3. It's AlBr3 minus. Okay. So one of the lone pair on bromine will take this hydrogen as a proton. Okay, and then the electrons from this CH bond will be pushed to the carbon with positive charge to regenerate the benzene ring. So first, we will get the isopropyl benzene product plus HBr as the side product plus AlBr3 as the regenerated catalyst. So that's for question number 5. Next, move on to question number 6. Question number 6. Compound G, 1-bromobutane, reacts with magnesium turnings in dry ether to form compound H. Treatment of compound H with carbon dioxide followed by acid hydrolysis yields compound G. Okay, so 1-bromobutane reacts with magnesium turnings in dry ether. Awak nampak je ada perkataan magnesium turnings in dry ether. That means compound H must be a Grignard reagent. Treatment of compound H with carbon dioxide followed by acid hydrolysis. Okay, this is carbonation of Grignard reagent. Yields compound G. Carbonation of Grignard reagent will give you carboxylic acid. Okay. So A, draw the structural formula of compounds H and J. B, write the reaction equation for the formation of compounds in A. C, compound G reacts with aqueous solution of sodium hydroxide to form 1-butanol. Provide the mechanism for the formation of 1-butanol. Okay, starting with question A, 1-bromobutane. So I will draw first 1-bromobutane. 1, 2, 3, 4. Okay, 1, 2, 3, 4. So this is 1-bromobutane. Reacting with magnesium turnings in dry ether produce the Grignard reagent. So that means Br ni awak ganti je dengan MgBr. This is compound H, the Grignard reagent. And then carbonation of Grignard reagent will produce compound G, which is a carboxylic acid. Okay. It's also important to remember that because J, okay, to produce J, this Grignard reagent reacts with carbon dioxide followed by acid hydrolysis. That means the acid, okay, the carboxylic acid formed by this carbonation reaction will have one extra carbon. Okay, the carboxylic acid formed from this reaction will have one extra carbon. You start with 1-bromobutane, but then the end product will be pentanoic acid. Okay. Next, question B. Write the reaction equations for the formation of compounds in A. So let's start with formation of compound H. We have the 1-bromobutane reacting with magnesium turnings in dry ether to produce the Grignard reagent. Okay, this is compound H. And then compound H react with carbon dioxide followed by acid hydrolysis to produce compound G, which is carboxylic acid. Okay, this is compound G. Okay, Next, let's take a look back at question C. Compound G reacts with aqueous solution of sodium hydroxide, NaOH, to form 1-butanol. Provide the mechanism for the formation of 1-butanol. Now, in this case, you need to remember that the nucleophile, okay, in sodium hydroxide is the hydroxide ion, OH minus. So OH minus is a strong nucleophile. Okay, this is a strong nucleophile. And the bromobutane, okay, the bromobutane that we use is a primary haloalkane. Okay, so primary haloalkane, when we use strong nucleophile, the reaction prefers SN2 mechanism. Okay, the reaction prefers to proceed via SN2 mechanism. That means in question C, you will need to write the mechanism for SN2 reaction. Okay, a one-step reaction. Okay, so I will write the equation, okay, the general equation first for this reaction. We have 1-bromobutane reacting with aqueous sodium hydroxide to produce 1-butanol. Okay, again, SN2 mechanism is a one-step reaction. So we will start with the attack of the nucleophile. Okay, we will start with the attack of nucleophile. Now, we will draw the 1-bromobutane in a tetrahedral structure. And then we have the nucleophile OH minus. Okay, so electron on oxygen, okay, will attack this carbon. So why this carbon? Because if you remember, carbon bonded to halogen is an electron deficient site. Halogen, okay, halogen is an electronegative. Sorry, bromine, okay, bromine, the halogen bromine is an electronegative atom. So it's more electronegative than carbon. That means bromine pulls electron density away from carbon. So bromine, in this case, has a partial negative charge, and this carbon has a partial positive charge. Partial positive charge means that it's electron deficient. Okay. The nucleophile attack from the back of the molecule with respect to this halogen atom. Okay, sekali lagi, the nucleophile attacks from the back of the molecule with respect to the halogen atom. And the nucleophile attack goes in at the same time as the halogen atom leaves. Okay. So we will first have the transition state. And then as the bromine atom leaves, we will get the product in the shape of an inverted tetrahedron. Okay, so this is the transition state. Again, key points to note. Okay, number one, attack by the nucleophile must occur from the back of the molecule with respect to the halogen atom. And then the nucleophile comes in at the same time as the halogen atom leaves. Okay, so the final product that you get, the 1-bromobutanol, Okay, must be in an inverted tetrahedral geometry. Kalau awak tengok macam bentuk payung dia ni, okay, asalnya sebelah kiri. Bila dia dah jadi produk, dia jadi sebelah kanan. So, mesti terbalik. Okay, so that's it for this video. Thank you so much for watching. I hope you gain something from this video. And good luck for your studies and for your PSPM too. Bye!